Italian alphabet. 21 letters instead of 26. Well, all right. Almost the end of the day, so I'm going to talk about. Thank you, Michael, for mentioning MCP server so many times. So if you didn't know, now I'm going to talk about MCP servers. So that's or what is MCP and why we are so excited about it. Who already use them? Quite some people. If you use Cloud Code, Copilot, you probably are using them and you don't know, right? They are part of the what we call agentic. Code development is part of everyday life, at least for me, and for you, probably soon enough. All right, so thank you so much for being here. I've been at SRE days in London. It was so much fun. I love the intimacy, the people together, they talk a lot. I met a few very cool people today, so I'm happy to be here, and I am looking forward to meet you outside after my talk. So we're going to talk about why agentic AI is such a hype, and honestly, I'm blown away. I can tell, I'm 49, so I've been around for a while on this planet. When I was born, all this was like a sci-fi, like a Star Trek. Star Trek, you talk in a thing, and something, the computer does something. And I'm living it, right? So I've seen all this transformation. I've seen the internet, I've seen the mobile phones. And now I see AI, and actually I pretty like it. I mean, I don't think it's going to destroy humanity, but I might be wrong, and I would be very sad if I'm wrong. I'll be dead anyway. But yeah, so I'm a technologist, so I'm very excited about technology. I'm going to talk about technology. I'm even going to do a demo today. Guess what? But first, the big guy. I joined Microsoft in 2016, 1 year after this guy. And I come from open source, and everyone was saying, why you join Microsoft? You traitor of the open source credo or battle. And I said, because of this guy. I joined because I read the writing on the walls. In fact, he steered Microsoft in the right direction, in the open source direction. Is the best place to do open source, and best place to be at the forefront, at the frontier of technology. And yes, agents will replace all software. I don't think so. You know why? Because agents are software. So there's nothing to replace. They're just different way to do the same thing, much faster, without thinking too much or spending too much time into details like coding. I mean, it's a thing of the past. Now we're all product owners and architects. We can tell agents to do things for us, and the world is a better place, at least the world of coding. So what is an agent? For a while I was struggling what is this agent? Is this Agent Smith from Matrix? Is this something that's gonna take my job? It's just software. It takes an input, calls an API, a model, the model responds, but then it does a bit something else, right? So it takes that request, it uses tools, does something more than just chatting with ChatGPT, right? So that's one-on-one interaction. It's just a conversational AI. An agent is that plus everything else that you need to develop software. Writing files on the file system, pushing to GitHub, or executing local commands can do a lot more than just talking to a LLM. So all these we call an AI agent, right? So the code is AI, so it would not be possible to have this without a model. Models are just very fast abacuses, abacus. It's just a very fast prediction machine. It's nothing, again, it's nothing magic. We'll say that every technology, I think it was Asimov, every technology is advanced enough, is indistinguishable from magic. But we know, we were there when the paper came out, we know what a LLM is, so it should not be magic to us engineers, right? So it's just a very fast computer that can predict the next word in a prompt. That's it. But then you can extend it with agents, with this plethora of tools like writing files, executing commands, and so on. But in the end, it's all there for doing something useful for us humans, right? So creating more value faster than by typing code one letter by letter, like function by function, and so on. So it is all there for us. So we think. At some point, we said, okay, these LLMs are super cool. They can do a lot of stuff, but not everything, right? So we cannot. They are kind of blind and deaf, and they cannot reach out to a database. They cannot reach out to an API. So how to do that? Well, you can, of course, write individual API interfaces for all these systems, or you can think of a universal API, universal protocol, right? So this an agent is this augmented LLMs, like a LLM plus tools, memory, can think about itself, can think about what is it doing. And there's this chain of thought. I don't know if you use Claude or Copilot, and you actually pay attention to what is writing in the window. It says, I think the user wants me to do this. I think I should do that, right? So this is pretty much like what a human does, what we do, right? So you're talking to me, I think you mean something like that, then I'm gonna reply to you in this way, right? So this is pretty much, we applied human psychology to LLMs, and that's pretty powerful, and this is also part of the revolution of the AI agent. So, but it's not enough, right? So there's always something outside the LLM. The memory of the LLM or the training data is never enough, right? So as much as we train them on trillions of parameters or all the Encyclopedia Britannica and all the books ever written, that's never going to be enough because it's not live. It's not something, it cannot get. Even if I train all the weather history in the last 50 years of the Netherlands, it will not tell me what is the weather now or tomorrow. So there's always something outside that we need to pick up, right? So we need to interrogate. And that's where the MCP was born, because it's like everybody was doing his own thing, like pretty much. It's always the case, right? So every new technology, people start to implement them themselves, right? So very bespoke. And then somebody, in this case Anthropic, of all the people, they came up with this specification. So MCP is just a document that describes the protocol. So it's just something that we all agree. Well, there was not even that much of an agreement. Anthropic say, this is the MCP protocol, use it if you like, but we are not gonna force you to do it. But because it made sense and it's just better to just use one way to talk to external tools, the industry, and I mean us, Microsoft and Google and everybody else, they start to use it. And even lots of hobbyists, like you go to GitHub, there's millions of repository listing all the MCP server people made. So you can make your own MCP server. We're gonna make one very quickly, if I have time. And it's just code. Just code that responds in a specific way to request. So it eliminates the many ports, right? So that's why we call it the USB-C of LLMs. Means that instead of changing the way the LLMs interact with every tool, there's only one way, and they're all the same, and you don't need to know the details of implementation because everybody uses the same spec. And that's it. There's nothing magic, again, like seems magic, but if we look under the hood, it's just a good old JSON, RPC, API calls, and so on. It's nothing. It builds upon other specifications like server-side events and HTTP. Nothing really crazy, but just put together in a very nice package so people can consume it. So of course, we all love it. Microsoft loves it. I want to show you how can you I work in Microsoft, so that's the tools I love. But this is applicable to any cloud. It's not. It's a pattern, right? So securing MCP servers, just a way that it's a pattern you can use in any cloud in any way. It's not unique to Azure or anything. But I want to show you how we do it in Azure and why we think that as every technology, the more people use it, the more we need to secure it, right? So if it's a hobby project, nobody cares, fine without authentication, like a YOLO. But if it's using a bank, then there's no way I'm not gonna implement strong security mechanisms and guardrails. So MCP is an open protocol that standardizes how we interact with from LLMs to tools and back. So, and the concepts are, they are hosts, so servers. MCP server is what provide the tool, right? So the thing that sits behind or before the databases, the weather service, the whatever you want to interact with, and the clients are we using Cloud Code or Copilot. That's a client and there's a server. So good old client-server architecture. I mean, it's been 35 years, it's still around. You know? So we're never gonna get rid of the client-server paradigm. And then you can have different servers, of course. So this is some of the servers we at Microsoft care for. The Azure MCP server, which provides an interface to Azure. The GitHub MCP server that provides an interface to GitHub. The Playwright and AI Foundry and the file server. So all these are interfaces, all talking the same language, MCP, that you can use to do interesting things. Like, for example, running a browser that can run your test visually. You know, it's a kind of a Selenium or something like a visual test of a website. But you don't need to go and take a screenshot anymore. Playwright can go do it for you, open a browser, take a screenshot, send it to LLM, take the response back and give it back to you after thinking. So there's a client, there's a server, easy peasy. What goes on in the middle, that's where we're gonna look into. 12 minutes, all right. And so MCP servers expose three things: tools, resources, and prompts. Most important are tools, really. Like resources are interesting for especially data-intense applications, but honestly, we all talk about tools. Even prompts, so MCP servers can actually tell you or guide the user, in this case the MCP client, which is LLM, into what prompts you should send it to him. But most of the time, we only talk about tools. We're going to focus on the tools. I think is the most important part of MCP specification is that an MCP server can expose tools, not only exposing tools, but also let the client discover those tools. So the tools are like API endpoints, but the MCP server reports the description of that, because the description is used by the LLM to understand if a tool is useful or not. So why you think this is nothing new, right? So we used to do this, right? So an LLM is a thing and is very useful, but how can we make it more useful? There are three ways, mostly. One is training. I don't like the training data. I'm just going to give more training data, so the response are better. It's very expensive. You need big GPUs, a lot of time, and probably a few billions. Not for the faint of hearts. What we came up with is retrieval augmented generation, which means I'm generating a response with an extra set of data, right? So you usually store this data in a database. Then you vectorize the data. The LLM can look into it before generating the response. So that response is a bit better, right? So it's a bit more grounded in real data. Not too bad, of course. We do it all the time. We just take I don't know, a bunch of PDF of legal contracts. We give it as a context, as a retrieval augmented generation data store to a LLM. The LLM makes a bit better response. Great. But this is still not the best way. What if I need, real-time data? I don't have time to do the batch back and forth. I don't have a database. I don't have Postgres or whatever. I want to just go and do my thing real-time. That's where MCP servers come in. So it's fast, it's interactive, and it's pretty inexpensive. Like whatever you have as an API already works. So it works like this, right? So there are three actors. Here there's an AI agent, there's an LLM, and there's an MCP server, in this case, GitHub. Let's say that I'm asking my GitHub Copilot, open a pull request about these problems, or I made a change to the code, go make me a pull request, right? So then I'm asking, the AI agents first thing, ask the LLM, makes a call, it says, hey, I want to open a pull request, and this is the description. And by the way, I have these tools, and it sends the description to the LLM. And the LLM says, oh, I think the user wants me to open a pull request. I'm looking at the description, and that's why you should keep the description of tools not too large, because that will be clogging the brain of the LLM. But then the LLM says Azure Foundry or whatever model you have. It's okay, among all the tools, I think I should use this one. For example, there is the GitHub MCP server expose a tool called open pull request with a description. So these are all sent to the LLM for interpretation, right? So the LLM says, oh, I think I can use this one. Then it sends back to the agent and say, hey, I think I know what you should do. You should call this tool with these parameters, go have fun. And in fact, the AI agent, my VS Code, my Visual Studio Code with Copilot or Cloud Code, makes this request, now complete with a payload and everything else, so it can go on, it can succeed, to the MCP server of GitHub, which is available at api.githubcopilot.com, something like that. Then it gets back the message, and it sends it back to the GitHub MCP server will respond with a payload, say yes, I opened the pull request, and this is the number. And then the LLM finally will tell the users, hey, I opened a pull request. Here's the link, and so on. What is all this back and forth between the AI agent and the server? It's just JSON. It's nothing, but it's not pure it's JSON RPC. So it's a way to communicate that is not strictly based on HTTP, but it's based on RPC. So it opens up a communication channel to the MCP server and sends a payload, which is JSON. And there are two ways to do that. There's one that is kind of legacy now, this server-side, server-sent events, SSE, where you get an endpoint, and then it's and then there's a way to do this. It's called SSE. It doesn't really matter that much, but then it's kind of a REST API call in the end. And then there's this, of course, the HTTP streaming or streamable HTTP, where you make a post to the MCP endpoint, and then you get a response. You make another call to say, oh, among all these tools, I think I can use this one. Just, I think eventually SSE will be deprecated. I'll show you how to do it with both. Normally, if you create a MCP server today, you probably want to do it in exposing both. So what I want to show you now, the demo. Everybody was waiting for that, right? So me also, because and I don't record demo. I don't do that. I just YOLO it. All right, I hope you can see. So I'm going to push this, actually. I'm not going to push it. I'm going to ask my agents to push. I think he already pushed, by the way. So it's on GitHub. So what and I'm not going to go through the whole thing, right? So I literally did not code any of this, right? So I said, okay, let's make me a MCP server that does something very simple, like let me put my glasses, because I told you I'm very old. I have been around, so eventually you get your eyes are not that good anymore. So you register tools, right? So this is important. You register tools, and there is this new tool which asks you number. I know it's not crazy. It doesn't make a lot of sense, but it's just to show you that you can do anything you want. Whatever is in that function, I can make it up, right? I can I can calculate pi or something like that. So I can, in this case, I'm just adding two numbers together. And then I have another function, so C, MCPR tool, which gives me a random dead joke. This is more fun than adding two numbers together. And then these also expose a number of endpoints to my MCP server is just an API server, pure and simple. What I can do here, of course, I can show you. So there is a thing called Model Context Protocol Inspector. So before that, of course, I run, it's in Go, so I can build it automatically. I can, let me know if you can see this. So before that, I want to show you that you can do, sorry. Okay, so this is the folder. I compile it, right? So go build something, and then I have a binary, and it's so simple, of course, and it compiles. I can run it, and I can run it locally, and I can give two numbers, and I think, I don't know, because I changed it, so, and then I can run it and then use cur to interact with it. All easy peasy, is local. And then, of course, I also push it to my GitHub repository. So I have a Docker file, and because I have only 2 minutes left, so I just want to show you that I have a Docker file, so you can build this in a Docker container, push it to Azure, right? So I have a Azure Container Apps that runs my Docker container with my MCP server. Easy peasy, a continuous integration, so as soon as I make some changes, it just exposes this. But what I want to do, so there is no authentication. Let's say that I'm actually using it to access my company's data or some medical information. This is not cool. I need to have, and when the protocol came out, there was no authentication whatsoever. It was like whoever makes the call, let him in. Now, the authentication is also in the protocol at this moment, but the industry moved on and said, well, if you don't build authentication authorization in the protocol, we're going to fix it with an API gateway. So we have an API gateway that it's here. So what does it do? It manages access to that MCP server. And I can show you there is a thing called Model Context Protocol Inspector. Oh, why clear? It's a web app, very simple, opens the browser, and you can see here that I'm connecting to the API management endpoint. So the API management endpoint is the gateway, is the firewall for my, and now I'm exposing only one server, but I can expose all my servers privately to my enterprise through private endpoints and so on. And of course, I have a key that I retrieve from the API management. So if I don't have the key, API management will not let me in. So this is just to show you that you can connect to the API server. So it's connected. I can list tools. For example, I have these tools. I can run it. This is just to show that what happens is that also you can see it here. There is a JSON payload that is being sent to the API management, then sent to the backend, and then I retrieve that joke. And what I want to show you also is, of course, who use agent like Claude or I don't know, Codex. Anybody knows that we also made a Copilot. Before that, I will show you. Yeah. So in Copilot CLI is in preview. It's basically an AI agent, coding agent that uses the same models as Copilot in VS Code. So I'm configuring some MCP servers over here. One is indeed the API management endpoint, and I can run Copilot here, and I see like it has 2 MCP server configured, and I can tell using an MCP server, please give me a dead joke. And you can tell because he's thinking, and you can also follow along and says, okay, I'm thinking, what should I do now? He's asking me to actually use an MCP server, so maybe I should use one. And execution failed. All right. Please tell me how much is 2 plus 2. Let's see if this time works better. It did work on my machine. I mean, it did work 5 minutes ago, but this is what it is. I know it's a lot of time to just calculate. Okay, maybe something is wrong. It went wrong along the lines, but I want to. If you want, I can come back next year and I'll show you. Of course, I hope to come back next year with a better working demo, but it kind of works. I'll show you. So there's now the rise of registries, right? So it's like Dockers, right? So everybody was doing containers, and then Docker came out with the idea of a Docker registry. And now we have MCP registry. There are also people hosting MCP Cloud, a friend of ours. I know these people pretty well, so you can host your MCP servers if you don't want to use Azure Container Instances or Azure Container Apps. There's a cheap, free way, or kind of cheap way to host them yourself. And then, just a shameless plug, I ran the Dutch Kubernetes meetup, now called Dutch Cloud Native and AI meetup, because AI. And we're coming with a conference next year in May in Amsterdam, in NDSM, in Amsterdam North, and it's about AI and sustainability. So if you care for the planet, please do. You should come, and it's going to be a lot of fun. And that's me. Thank you for your time. That's my meetup, 4,300 members, not so bad. And that's my family. It's me, my wife, and our 5 kids in Greece, and it's pretty nice. And I want to thank you very much for your time. One question.
Yeah, we have room for one question. Anyone? Oh, yes.
Hey, thanks for the presentation. It was a nice one. You said you will come next year with the better demo, but what do you think the next year would look like in this case?
So when I submit this talk, MCP was new. I mean, it's crazy, right? So I mean, we used to talk next couple in Lustrum, right? So 5 years from now, and now we think about 5 months from now. I really don't know. I mean, I wish I knew, but I don't really. It's hard to say. There's also the A2A. Maybe next year I'll talk about the A2A protocol, which is agent-to-agent protocol. I haven't looked into it yet, but that's why we are here, right? So to learn and fail. But I hope Claude is working. But anyway, thank you.